Welcome to a quick demo on the use of this ring to trammel your milling machine. A little while back I was fooling around doing a trammel job on this machine in particular, and I didn't like the way the traditional methods went. It seemed like there was a lot of moving of the indicator pin, moving of the arm, moving parallels, a lot of parts going in uncontrolled ways. It didn't seem like it was a good idea, and I thought that maybe just moving the indicator in the path that it wanted to move in, which is circular, across the tabletop made sense. So I did a little research and I found that a lot of people were doing exactly that, but they were using bearing races for a ring. Well, if you look at the ABEC tables for bearings, unless you get a really very, very good bearing, the tolerance on flatness and parallelism from the top of the race to the bottom isn't very good. So you're using something that is kind of inherently flawed to get around the limitations of the more traditional methods. So I thought about it. I said, well, what if I came up with a ring, or I guess you'd call it a bearing race. It's not, but it's just a ring that is indeed very, very flat, and it's very parallel from top to bottom, so that inaccuracy in the ABEX bearings is gone. You've eliminated that, and now you can move the indicator all around the circle however far you want, 360 degrees if you need to, without having to move the pin, move the arm, move any parallels, move any gauge blocks or whatever it is you're using, and still see because it's extremely parallel, you see exactly what the table is doing, not what's going on with the gauge blocks or the arm or any of that business. You're actually, because this is essentially, this is just an offset of the table height because it is so parallel, it removes all of this tripping across the T-slots and all that business. So in any case, I came up with this. The spec on it is very good, and I hope that you'll see that it's an improvement over a lot of other methods. Maybe you guys have a method that you really, really like and it's better than what I'm doing, and if you do, then that's fine. But if you don't, I'd love it if you took a look at this and tried it out, because I think you'll like it. In any case, I've tilted the head of this milling machine just a little bit. It's as if you had done some milling job and you move the head back to kind of close to being squared up again, but it's not dead on. So you want to get it just right by using an indicator and tramming the head. So you get it sort of close using the usual markings on the column as you typically do, and stop there. Put the ring down on the table, set up your indicator just as I have here, and you can do this both axes, x-axis and y-axis. You can do them simultaneously if you like. I don't recommend it, but you can, in this case, because my mill only tilts along the x-axis, we're going to do that one. If you've got one that nods, like most of the stage 1 Bridgeport style knee and column machines do, then if you've got a nod in the machine as well, then that's fine, because you can do this axis and get that squared up, and then do this axis with exactly the same setup. You don't have to move anything except for this. All you got to do is spin this around and do the numbers, and you'll be in great shape. So let's do this axis, and I'll show you how simple this is. What I've done is I've set the pin down on the ring, zeroed it, you spin it, and this is located pretty much as far out on this side of the x-axis as it'll go. Spin it around to the other mark, or near the other mark. We see that we've got about 58 thousandths difference from this side to this side, and according to the way the needle moves, it's saying that the head has got to be tilted. The spindle has got to go that way from where you're looking at it. So if you're using a Bridgeport style machine, then all you do is, as you guys know, you just crank the worm on the top a little bit and you're rocking. For this kind of machine, I actually have to hit it a little bit. Half of 58 is 29, so we want to see 29 on the dial when we get all done, and just fortuitously, that's pretty close. I did that with one whack, and it isn't usually the way it works out with this machine, but I got lucky. So we'll see how this goes. So we re-zero the dial. You don't have to, as you guys know, but we'll do that for this video. We re-zero the dial, crank it around, and see how this axis looks. And I'm off by 2 thousandths from one side to the other. And let me bump that just a little bit. It's got to go. Got to go back that way. Let's see how this goes. And re-zero. And we'll spin it around to the other side again. And I'm off by, oh boy, I'm off by 1/2 thousandth going from one side to the other. So I could bump that again. I guess I will, just to be a good guy. Bump that again. Zero again. Zero deflection. So in just a couple of moves with kind of I guess you'd say a primitive way of adjusting the head, very primitive compared to most stage 1 style machines. I was able to do this in just a matter of a couple of minutes and do it to literally zero deflection. There's no movement of the needle. And again, if you're using a stage 1 machine and and you've got nod in the machine, in other words, it's forward to back, then at this point, all you do is just move the pin, the indicator, to the front to rear location along the y-axis, and you just do the same process over again, and you're all set. Your mill is now trammed, and you're in great shape. Another use of this ring that I find particularly handy is because it is very robust. It's about 3/4 of an inch wide, about an inch tall, very solid. It's made out of tool steel. It's been hardened. It's 4140, by the way. You can use it for just general fixture work. If you've got a bunch of holes to drill or some milling, you've got a good sized plate that you need to put on your machine that won't fit in a vise. This is really, in some cases, this is tremendously better than ordinary parallels or blocks that you might use to set the work up off the table, because it's a ring. It's inherently stable. You throw it on the table and it doesn't tip over when you go to put something on it or put the clamps on it or any of that kind of business. It'll hold the work. You can set work on it, and you know, because of the certification of the ring, you know that it's dead parallel with this surface. So it makes a really nice stable fixture that you can use in a milling or drilling process that you might ordinarily have to stack up a bunch of blocks or get some parallels to do. In any case, that's the demo. I hope you try it out. I hope you like it. If you don't, I'd love to hear some criticism. Otherwise, enjoy, keep it for a little while, and use it, and let me know what you think. Thanks a lot, guys.